Okay, hi guys, we're going to be looking at rules of indices. In this video, we're just going to be looking at all the rules and just doing some basic examples using the rules. In the next video, I'll do some more complex examples where I'm combining multiple rules together. So we're going to just jump straight to it because we've got a lot to get through. So to start off with, we have our first rule. And our first rule is that when I have something with a power multiplied with the same thing, but with a different power, or can be the same power, then I just add my powers together. And you need to memorize every single one of these rules. You are not given them. You have to memorize it. So as a few examples very quickly, if I had x3 times x4, so x to the power 3, x to the power 4, all I do is add together the two powers, so that's just going to be x to the power 7. If I had y to the power of 5 times y to the power of negative 3, again, I'm adding the powers together, but I must be adding that negative in there as well. So realistically, if I've add negative 3, well, a positive and a negative makes a negative. So I'm actually doing a takeaway, so that's going to be y to the power 2. If I have 2b to the power of negative, let's go with negative 3, times 8b to the power of, let's do 8. Now, if I was unsure how to do this, I can actually just reorder it. So you don't have to do this, so I'm just going to change this in a different colour. But I'm just going to change the order to 2 times 8. So I'll put my two numbers here together. And then I'm going to have times b to the power minus 3 times b to the 8. Some people, if I just change this order a little bit, it helps them see what they need to do next. So I can do 2 times 8, which gives me 16. And then I've got b to the power minus 3 times b to the power 8. So that means I'm doing minus 3 add 8. So my final answer is going to be 16b to the power of 5. And obviously, if you are feeling confident, you can just completely ignore this second line here. You can just jump straight to thinking, well, 2 times 8 is going to give me that 16. And then I can see my powers are here. So those need to add with the b. But again, just wanted to do that little line there as a little explanation. Okay, second rule then. So this time we are having, so let's do a to the power of n divided by a to the power of m. This could also be shown as a fraction, because remember, a fraction is just a division. And now think, when I multiplied, I added the powers. So when I divide, and dividing being the opposite of multiplication, that means I'm doing the opposite of division. So I am doing n minus m. So it is just the opposite of a multiplication. This time I just subtract. Ooh, that's fine. So as a couple examples, if I have x to the power of 3 divided by x to the power of, let's do 2. That is going to be x to the power of 3 take away 2, which is x to the power of 1. Or something to the power of 1, it's just going to be the same thing. If I have m to the power of 6 over m to the power of minus 5. Again, my fraction is just a division. So I'm doing m to the power of 6 take away negative 5. Now remember, when we have two negatives next to each other, that actually, two negatives next to each other, that actually turns into a positive. So that's going to be m to the power of 11. If I have, this time, I'm going to have 12 b to the power of 3. Actually, no, let's not do 3. Let's do to the power of 8 over 8b to the power of 2. Now, when I've got a mixture of the letters and numbers, I like to try and think of them separately. So what I can do to help me out, I'm actually going to create a little split down the middle here. So I've got 12 over 8 and then b to the power 8 over b to the power 2. And now I'm going to simplify that fraction. Well, I can divide both things by 4. So that's going to turn into 3 over 2. And then there's going to be b to the power of 8, take away 2. So that's going to be 3 over 2 b to the power of 6. Okay, so that's my second rule. My third rule then. So the third rule is when we have brackets like this, we are then going to have our powers multiplied together like that. So when I've got my brackets with a power inside and power on the outside, then I multiply my powers together. So, a couple of examples of that. If I have, if I have b to the power of 3, oh, that 3 is not very obvious, to the power of 5. I'm just going to be doing 3 times 5, which gives me b to the power of 15. If I have 2 to the power 2, and that's also going to be to the power 2. If this question was asking me to evaluate, I'm multiplying my powers together. So that's now going to be 2 to the power of 4. And then if I was to do that 2 to the power of 4, make sure when you do have a number with a power, you do actually figure out what it is. You don't just leave it at that point there. So 2 to the power of 4, so 2 times 2 times 2 times 2 is going to give me 16. And then just one more very, very quickly. If I have, let's do c to the power of minus 3 all to the power of negative 2. That's going to be c to the power of negative 3 times negative 2. 2 negatives make a positive, so I'm going to have c to the power of 6. Okay, so my next rule is not always a rule that is on its own. I like to include it because it just sort of bridges the gap into more complex versions of this third rule. So what I call my fourth rule is that when we do have a bracket, if we have more than one thing in it with a power on the outside, that power affects each thing in there individually. And any rules that might coincide with it, e.g. our third rule, that is going to come into effect. So just an easy example to start off with. If I have x, y squared to the power of 4. So the x is affected by the 4 separately. The y, well, it's already got that squared there. So imagine this wasn't here. Imagine we just had this y in the bracket on its own. From our previous rule, we know we need to multiply those powers together. So we have x to the power of 4 and then y to the power of 8. Now, if we were to start to have some numerical examples, so I'm going to have 3, let's do t to the power of 8, and that's going to be to the power of 2. I'm now going to have 3 squared and t to the power of 8 times 2. So 3 squared is 9, and that's going to be t to the power of 16. One more very quickly. This time I'm going to do, let's do 2a to the power of 3 and b to the power of 8. And it's all going to be to the power of 3. So this cube is going to affect each thing in that bracket individually. So I'm going to have 2 cubed. Then a, well, it's already got a power, so that means I'm going to be multiplying the power it already has with that power on the outside. Same with our b, going to be multiplying the power it already has with the power on the outside. So 2 cubed, that's 2 times 2 times 2. It's going to give me 8. Then that 3 times 3 is 9. Then that 8 times 3 is 24. Okay. Next rule then. So this is our 5th rule. Super easy one. Anything to the power of 0 is always equal to 1. No matter what it is. So this is actually one of the ones where, for this first example, I am going to combine one of my other rules to show it off. So, for example, if I have x to the power of 5 times x to the power minus 5, I know I need to add those powers together. Well, 5 take away 5 is just going to be 0. So that's going to be 1. One thing to be aware of is if I have something like 3m to the power 0, just remember that when they are right next to each other, that means they are being multiplied together, like so. So it's only this bit here that is affected by that power of 0, not the 3, just the letter. So that means this is then going to be 3 times 1, which is just 3. And if I had some complicated thing going on in here, no matter how big it is, if there is a power of 0 on the outside, that means this whole thing is being affected by this power. So it is just going to be 1. Okay, 6th rule, almost there. This one, if I have something with a negative power, I can rewrite that as 1 over that thing with the same numerical value of a power, but I basically just lose that negative sign. So sometimes a question might say, right, or let's actually just change that to simplify the following give your answer with a positive power. And this is a sort of question where this rule would come into play, purely for this fact that is asking for a positive power. So as an example of that, and yeah, this one I'm actually going to include one of my previous rules. So if I have x over x to the power of 4 over x to the power of 7. So that's going to be x to the power of 4 take away 7. So that's going to be x to the power of minus 3. Now, if we look right now, my power is negative, but we want a positive power. So that is when I can use this rule. So put it 1 over x to the power of 3. Okay. One thing, actually we'll do one more very quickly. So this time I'm gonna do actually no, we're gonna chat about one thing and then we'll do one more example using this new thing. So if I have 3, let's do n to the power of negative 2. Now, similar with our previous rule, this negative 2 only affects the thing it's directly next to. Unless there's brackets around it, it's only the thing it's directly next to. So that means we have 3 times, again, that n minus 2. So that'll be 3 times... Actually, I'm going to keep it in green because this stuff here isn't actually needed in your working. So 3 times 1 over n to the power of 2. Or n squared even. And so that means the 3 just stays on the top. And then we have n squared on the bottom. So again, it is only affecting the thing it's directly next to. Whatever is not actually affected by the power just ends up on the top of the fraction. So as a further example of that then, if I had something like 3, well, let's not do 3 actually. Let's do 2b to the power of minus 5 all to the power of 3. Again, I would go through the same way as before. 2 cubed is 8. I've now got b to the power of minus negative 15. And then, because I want it with a positive power, 8 is not affected by negative 15. 8 is on the top, and on the bottom is b to the power of 15. And then our last rule, we're almost done. This time, if I have something with a power that has a fraction, I can rewrite it in like this. Now, I have a little thing to help you remember where the m and the n goes. So, if I was to imagine my power again, so that n over m, but this time I'm going to just draw it as a little flower. And the phrase that helps me memorize is, the bottom is the root, the flower is the power. Ooh, just about fit that in. So, the bottom is the root, because this is my square root here. And then the flower is the power. So some examples of that in work. So if we had 9 to the power of 3 over 2, I'm going to have this root sign. The 9 is going to go underneath. Now the bottom is the root, so that's going to be a 2 in there, and the flower is the power. So when there's a 2 in there, it means we're doing a square root. So square root on 9 is 3. And my power is still 3. And then 3 cubed is 27. This time, let's do 16 to the power of, let's do 3 over 4. So again, I'm going to have this root sign, 16 goes here. Now the bottom is the root, and the flower is the power. Now, if I don't know what number times by itself, 4 times give me 16, I always just think, well, start off small. Obviously, 1 times 1 times 1 times 1 isn't going to give us 16. And then I would go up to the next one. I think, right, what's 2 times 2 times 2 times 2? 2 times 2 gives me 4. Times it by 2 again is 8. Times that 2 again gives me 16. So that is going to work. And if that didn't work, then I would go to 3. And I would continue until I hit the number. So that's now going to be 2 to the power of 3, which is just 8. And now let's do 27 to the power of 2 over 3. So again, my root sign, gonna have 27 underneath. The bottom is the root and the flower is the power. If I didn't know what number times by itself 3 times gives me 27. Again, start small, so 2 times 2 times 2 gives me, that will be 8. That's not going to work. So let's do 3 times 3 times 3. Well, 3 times 3 is 9. Times it by 3 again, 27. Ooh, that's my cube root. So that's going to be 3 squared, which is just 9. Now, there's one other way that this type of question can be asked. So still using my 7th rule, it might ask the following. Write the following with a fractional index. So it's just saying, write this thing out again, but this time we want the power to be a fraction. So if I have an example like root x, I'm gonna have the cube root of x to the power of 4. So I know we're gonna have x as our base. Now the bottom is our root, so that means 3 is gonna go down here, and the flower is our power, so that means 4 is on the top. If I had my 4 there, I'm gonna have b, but there's nothing on the outside, so I've got a little blank up here. If there's nothing there, then that just means the power is 1. So if I was to write that with a fractional index, it's going to be b, the bottom is the root, and the flower is my power. And then one last one, and then we're almost done. Ooh. There we go. And let's just do 2a this time. And let's make it to the power of 5. Now, this case, I don't have anything in here. Now, think, when I've got that normally, we say it's the square root. We know the square root is one number times by itself twice to give something. So that means the 2 is in there. So I'm going to have 2a, the bottom is my root, and the flower is my power. And so those are all our rules of indices. And yes, again, you have to memorize every single one. I recommend just writing out the rules again and again and again. And the more you write it out, the easier it will be for you to recall all these rules. So yeah, so in the next video, I'll do some examples where I'm combining a bunch of the rules together, just so you know how to tackle these more complicated rules of indices questions. But until then,